Well, thank you all very much. We really appreciate the opportunity to be here with you today to share some of our experience in school design and what we refer to as 21E, which is 21st century education and zero energy. So bear with me while we go through just a short introduction of what Kentucky's known for, and some of you all will recognize some of these things. Certainly, horse racing, we're all familiar with that Kentucky tradition. And if you're into bourbon, the Bourbon Trail just keeps getting longer and longer as that industry continues to grow. And then I think if you're not familiar, we have a little bit of a rivalry with you guys in Kentucky basketball, and then certainly Kentucky Fried Chicken. But one of the things that you may not know that we're known for is also zero energy schools. Justin and I worked together on the very first zero energy school in the nation in Richardsville Elementary. Gosh, that's been a decade ago now. And then most recently, Kentucky's second zero energy school that now has a year of operation under its belt, and that's Jennings Creek Elementary. So just to get through a couple of the definitions which continue to evolve, what is a zero energy building? And the graph on the right, this is what the kids at the schools in Warren County, saving energy is really part of the curriculum there. And so this is how they explain it. Energy is produced at the power plant. It goes to the school for consumption. The school also generates energy in the form of solar panels, which is put back on the grid for clean green energy for everyone to utilize. And so basically it's just an efficient new construction. You can even be a retrofit project, but you have a net zero energy consumption over a typical year of operation at the site. Now, the definitions continue to evolve a little bit. And so what we were referring to a couple of years ago as net zero is now called zero energy. And basically that's the dramatic energy reduction that I mentioned, plus 100% renewables, typically solar panels, and in some cases wind. But you have 100% of generation to cancel out all of your energy use. And then another term that has is zero energy emerging. And basically what that means is the same dramatic energy reduction strategies plus a percentage of the renewables, such as a phase one. You may not have enough in your budget to add 100% of the solar power, but you have a phase one, so you have a portion of it. And then the latest sort of trend is to call a school nearly zero energy. And basically that means that we're still using the same dramatic energy reduction strategies. We just don't have any of the renewables on the site at the present time. Now, it's really important to understand how we measure energy performance. And, you know, everybody's familiar with automobiles, miles per gallon, and the higher the number, the better. So we're all familiar with that. And a building's energy is measured in a similar way, only we want the lower number. And it's really expressed in kilobTUs per square foot per year, but that has been shortened to EUI, which stands for energy use intensity. So again, the key here though is to recognize that the smaller number is actually the better energy performance. Now, we're in climate zone 4. And so ASHRAE has a guide that you can look at, and you can determine what a typical school would use in energy in any climate zone. And so it's a great benchmark to have to know kind of where to start looking for energy savings. So we're at 73 EUI if you just build a school to meet the minimum requirements of the building code. Now, I mentioned a benchmark, and I think this is interesting to show because you can see sort of how far we can get to in that dramatic energy reduction. So at the top, that's the typical school at climate zone 4. We're all familiar with Energy Star, and we all assume that that's a good place to start, and it is, but you can see that you're still at the threshold of Energy Star 51 EUI. Now, if you go down to a LEED certified building, and you have a 50% reduction, then you'd be at 36. We're going to talk a little bit about our first school that we really started to look at energy saving strategies on. That's Alvaton Elementary. We were able to get that one down to 34 EUI. And then before we did the first zero energy school, there was American Recovery and Reinvestment Act grant that was issued in Kentucky, and we qualified for a zero energy grant, but they set the threshold for 25 EUI. So you can see, to go from 73 down to 25, that's a pretty big jump in energy reduction. And then Richardsville, that's the first net zero school, we were able to get down to 18.2. And the school that I mentioned earlier, Jennings Creek, with a year of operation under its belt, we've gotten it down to 15.5. So certainly dramatic energy reduction is critical to the strategies that we're talking about. Now, I mentioned Alvaton Elementary. This was the first ICF school that we had done. Prior to that, we designed schools like everybody else. You know, they were typically masonry buildings, sometimes steel frame and infill, but this was the first ICF school. And honestly, we weren't necessarily looking for just energy performance. We had a very tight time frame to get this school built because the district had already initiated a redistricting. And so we had 13 months to get this building in operation, and the insulated concrete forms allowed us to cut about 3 months off the schedule of construction. These are just a couple shots of the building inside and getting down to the 34 EUI. We did a few things, just clear story lighting, but nothing that I would consider critical other than the building envelope at that time. And then I mentioned the insulated concrete. There's a kind of a misnomer about insulation, and you know, I've heard arguments before about, well, we can insulate in different ways to reach the same insulation as an insulated concrete form. And while that is true, that's only half the story. The thermal mass is critical to the performance of the building. And when you have 8 inches of solid concrete flanked by the the foam on each side, that is an incredible amount of resistance, I would say, to the environment. And so that's where you pick up a building system that really is unmatched. Now, one of the things that we had to recognize early on is that in order to get that energy reduction to the length that we were talking about, we had to understand how to reduce energy. You know, I mean, we had typically designed schools the same way everybody else. You design the building, you meet your client's needs, and then you turn it over to the engineer to figure out how to make HVAC system efficient. And that simply will not work any longer. You have to have a coordinated effort. And then as the architect, we have to realize that every single design decision we make, no matter how small, is going to have an impact on the energy performance of the building. Now, this is something that was very difficult for me to get through my own head, you know, at the time that we started this, because we're all familiar with changing behavior to conserve energy. And that's simply turning the light switch off when you leave the room, or turning the thermostat down at night because it doesn't have to be as warm as the conditions need during the day. And that, we've always known that that's a good way to conserve energy. And the idea is to simply not use it, turn it off when you don't need it. Now, what we're suggesting, though, is a shift in the way to think, and to say, well, it's not necessarily using it, how to design it so you don't need it to begin with. And so that changes the way you think about designing buildings, and it becomes a snowball effect. Because if you increase the building envelope's performance, well, now the HVAC system is going to be sized differently. You don't need near as much tonnage. And so that snowball effect starts to take effect, but you really have to change the way you think about design in order to do that.
So let's look a little bit at Richardsville Elementary. Again, as Kenny mentioned, now nearly a decade old with nearly 10 years of operation. Richardsville was the first net zero or zero energy public school in the nation, built in Bowling Green, Kentucky, for a client that we've been working with now for close to 30 years. So we had a long tradition of working with them and kind of raising the bar for our energy performance on each school. And we were given a challenge, what can we do to reduce the energy consumption on this elementary school to where net zero or zero energy could be attainable through the introduction of a solar array. So you can see some of the facts for Richardsville Elementary on the left hand side of your screen there. Built for 550 students, grades preschool through fifth grade, and then there the construction costs included as well. But a energy use index of 18.2. Uh, Richardsville Elementary not only was kind of a learning opportunity for us as architects, but it's also been and continue to be used as really a learning tool or a teaching tool, even with the students. On the right hand side is actually the president of the University of Kentucky visiting Richardsville Elementary. And one of the rewarding things about this facility is the fact that the students in this facility know the building better than we do, even. They can tell you facts about the school. They can tell you about the energy consumption for Richardsville and even about the design strategies that we employed to be able to reduce the energy consumption. You'll also see things such as rethinking the way that classroom lighting was done. Now, we have since kind of evolved from the Richardsville model here, where we've got a number of clear stories and a lot of light sensors within the classroom. We have kind of clarified that and made it a little less complicated as we've evolved. But again, even rethinking some things such as the classroom daylighting was something that we looked at the time. Uh, we also looked at ways to introduce natural light even within the heart of the building. So even within the core spaces that you would typically see in an elementary school, typically you can always tell the gymnasium or perhaps the cafeteria because it's usually the big box that's tacked on the end of the building. So we actually used Richardsville is much like a donut shape in plan, and the large volume spaces are actually in the center of that donut. And then we introduced a long clear story spine to help get natural daylight into the core or the heart of the school. Uh, Obviously, with any zero energy project, offsetting what energy consumption you have is always a goal. We first looked at the roof, and you'll see the solar array on the right hand side there that's actually on the roof of Richardsville Elementary. And then, in addition to the roof area, we actually also had to introduce a PV array in the parking lot that has some covered parking spaces that were introduced out there. Uh, two reasons there. One, it's great to have the solar panels up and protected, like a space like the roof, so that it's reduced vandalism. But you also want to be able to showcase and highlight and let everyone see that the school is indeed zero energy or zero energy emerging. As Kenny mentioned, we did kind of rethink how we have done design, and we've been now looking at this and really uh, evolving our strategies for zero energy over the last 10 to 13 years now. But we've really kind of developed a recipe or a set of design strategies that we utilize to really help us get and maximize the energy reduction that we can get in any school building. So you'll see those on the left-hand side: site orientation, high performance thermal envelope, maximize the building system performance, the building size and making the building as compact as we can make it. Renewable energy source, traditionally in Kentucky, that has always been uh, a PV or solar array, but we can also look at wind or other renewable energy sources. And then finally, the last component there that we're big believers in is not only just designing a building that performs well, but also is a learning tool or a teaching tool for the students. And we're able to energize the curriculum in working with students and staff and all those end users that are going to occupy the building. So in looking at the design strategies, obviously the first strategy is proper site design and building orientation. We know that historically, any building on a site would historically address the road or the building front or the property frontage at 90 degrees. Well, so that we can take advantage of not only natural passive daylighting, but also the thermal performance that Kenny mentioned previously, we want to look at an orientation that takes advantage of putting the long axes on the at true north or true south. Basically, you can see on this concept, the Richardsville Elementary site, the building does not sit 90 degrees to the front of the property. It's actually rotated at about 15 or 20 degrees off of that 90-degree axis. So we could fully take advantage of the daylighting opportunities and for that thermal envelope opportunities as well with the thermal mass. We talked about, Kenny talked a little bit earlier about thermal mass and about high performance building envelopes. While we have seen a dramatic energy reduction in a combination of concrete masonry units with thicker insulation, we've not been able to achieve the same results that we've seen with insulated concrete forms due to the thermal envelope, the superior thermal envelope that we've seen, and in large part related to the thermal mass properties that you get with the solid 8 to 12 inches of concrete on the exterior of the building. So let's compare in thinking through kind of the high performance building envelope, if you will. The prototype percentages are listed on the left-hand side, and we actually study these on each project that we do. We will review the exterior wall to floor area ratio, and you can see how Richardsville was below what we would typically see in the prototype. And we also look at the window to floor area ratio. How many openings do you have in your building envelope compared to the floor area that you have? And then obviously, as we look to reduce the building's contact with the outdoor environment, we also definitely do not want to forget about the roof to floor area. So we actually look at how much roof exposure do we have relative to the floor area. So at Richardsville, for instance, rather than a long sprawling one story, it was actually a 2-story model that reduced the roof area to 62% of what you would typically see on a 1-story school, for instance. I mentioned a little bit about Richardsville plan. As I described the donut kind of plan before, the classrooms are what you see in blue, and those are primarily distributed along the north and south elevations, which the north elevation would be straight up in this image, the south being straight down. And then the large volume spaces in the core of the donut plan, those are indicated in yellow there, with those being the gymnasium and the cafeteria. One thing that I'll also mention is Warren County, who as I mentioned, we've been working with for close to 35 years now, had developed a standard to increase the volume of the cafeteria so that it could be used as a multi-purpose space as well. So while the left-hand side looks in plan like a gymnasium, it's actually used as a cafeteria, but striped for gymnasium so that they can use it for other activities. But above that cafeteria space, you'll also see another space there that's colored yellow, and that's actually a very compact and well-planned kitchen space that we'll discuss a little bit further. Uh, Geothermal is also something that we have been utilizing throughout the state of Kentucky for probably 25 years now. It's something that is very familiar with most of our school clients. So it wasn't something that something foreign to Warren County. It's not something foreign that we really have to discuss with any of our school clients because it's something that they're familiar with. We did introduce some new techniques and some new energy saving opportunities at Richardsville and subsequently in many of the uh, zero energy buildings that we have done. And that is looking at dual compressor heat pumps and distributive pumping. Rather than having a series of pumps that may sit in a mechanical space and pump 24/7, pump hydronic water throughout the building 24/7, many of these schools that we'll be looking at today actually have individualized pumps at the heat pumps, the individual heat pumps that call for water as they need them rather than sitting there running 24/7 with a central pumping system. We also look at outside air ventilation, and this is something that has become very familiar for most of our school clients over the past 10 years, but was kind of different and new at the time. But rather than constantly pumping fresh air into spaces that are even unoccupied, we actually look at demand control ventilation that looks at occupancy and only calls for introducing fresh air into spaces that are occupied and as needed rather than constantly exchanging and turning over fresh air in spaces that wouldn't necessarily require it. I talked about the kitchen at Richardsville, and this is a photo of that. Again, once we started to look at energy usage throughout the building, we also realized that we also had to take a deep, hard look at the energy consumption that was taking place in the kitchen itself. You'll see that all of the grease-laden equipment, all of those pieces of equipment that produced grease and were dramatic, big energy users in the kitchen were eliminated in favor uh, of deep. We eliminated deep fryers and tilting skillets and replaced those with combi ovens and other pieces of equipment that could not only help us to reduce the energy consumption for the kitchen, but also allow us to cook in healthier, just look for kind of a comprehensive approach to the kitchen itself. And we really have to give a lot of credit to the Warren County food service folks. They really kind of grabbed this and took a really good approach to completely changing this. Richardsville Elementary actually does not have a computer lab, which in the state of Kentucky, we have a model program that defines each and every type of space that a building, an elementary school of this size should include. That would typically include at least one computer lab. That would be a place basically where computers would be parked around the perimeter of the room and students could come to that room and for testing or other opportunities. Again, over the past 12 to 13 years, as technology has changed, this has become more and more common for laptop carts to replace computer labs, but this was a very progressive approach at Richardsville at the time with the elimination of the computer lab and then again reducing the energy consumption that each one of those plug loads, each one of those computers was taken at night and throughout the day. We also look at living building strategies and life cycle evaluation. We introduced stain polished concrete throughout Richardsville Elementary in the common space and even in the classrooms as a way to not only reduce the maintenance costs, but really reduce all of the costs that they would see with janitors and really the ongoing life of the building, all of the cost of the materials, the finishes, and the equipment, all of those were impacted by these life cycle evaluations. This is actually a picture of Jennings Creek. As Kenny mentioned, zero energy, a brand new zero energy facility for Warren County, the same district as Richardsville. A couple of things that you'll notice, again, you'll see it. A lot has to do with the advancements in the technology, but we have been able to get all of the PV, the renewable energy source, on the roof of the building in this case. But again, where Richardsville was a very compact building footprint, Jennings Creek is still very compact, but not nearly as compact as Richardsville. Yet we continue to see an even greater and dramatic reduction in energy consumption. So again, just some advancements since Richardsville, which we really consider the grandfather of all of these buildings at this time. I talked a little bit earlier about Richardsville and the pleasure that we've had in seeing the kids speak about the building performance and about the design strategies that have been employed at that building. Warren County has really taken advantage of this, not only the green energy and the ability to offset energy costs, but also to educate their students and to allow their students to not only educate visitors within the district, but to use those kids and go off on their energy teams and really teach others about the exciting things that are going on in Warren County and in Bowling Green, Kentucky. We always like to say proof is in the pudding. And certainly the utility bills for Warren County, both at Richardsville and Jennings Creek, you can quite quickly see the results of the dramatic energy savings that both of those schools see as zero energy schools. But they presently not only do not have an energy bill each month or throughout the year, but at the end of the year, they have currently been getting a check for some $35,000 a year in energy savings. So not only, they're actually not just zero energy or net zero, but they're actually net positive for the district and have, you could equate this to roughly the starting salary of a beginning teacher.
So at this point, we want to ask the question, should zero energy schools be considered the new normal? Is this the way that schools should be designed today and tomorrow? And we certainly think so. And I'd just like to show you, since Richardsville, just some of the buildings that we've been able to design and get online. And I've attached the associated energy use intensity for each of those. And if you remember early on, 25 was really established as the threshold for us going forward. We knew if we could get buildings to perform at 25 or less, then it's pretty easy to add the renewables that you need to take it all the way to zero at a much reduced cost. And so there's those, and we don't always have to do elementary schools. The building on the left is actually a college and career center, and we got it down to 23.5, and a lot of specialization in that building, from auto repair. They also have welding. They also have food service, culinary arts. So a lot of energy use in that building. And then the one on the right, this one is pretty amazing as well. This is also in Warren County. This is the largest school facility in Kentucky. It is middle school, high school, joined at the hip, and it's 334,000 square feet. At the time it was constructed about, I think 6 to 8 years ago, it was the largest ICF facility in North America. Every bearing wall in the building, both inside and outside, was ICF. And so You know, a high school traditionally will use more energy than any other school facility. And a lot of that is due to the fact that it just stays open longer. You know, high schools are used 7 days a week, and they're usually open much later at night. So they're just used more. But to get at 22.1, it's pretty exciting on that building. And then just here's some more other schools that we've done. Again, as Justin mentioned, our daylighting strategies have evolved with the introduction of LED lighting very effectively and very cost effective as well. But we still like a lot of daylighting in our buildings anywhere we can get them. And we've talked a lot about energy, and that's important, but it can't just be about energy. And so we've developed strategies to incorporate 21st century learning into our designs. And basically, if you're familiar with the 21st century techniques, it's recognizing that not all school children learn the same way. And so they have to be adaptive learning spaces that enable each child to perform at their best potential. And so what we've done is we've incorporated different types of learning environments within the same building. And as we look to do that, one of the things that has happened is the same strategies that we've used for 21st century education also enhance the energy performance of our buildings, especially when you're looking for spaces for small group study, individualized study. A lot of times we're taking what would have been corridors and circulation in the building and carving those out to create spaces for learning. And that aids us in making the buildings more compact. Now, the other thing is, as architects, we know about the 2030 challenge, which says that by the year 2030, all buildings should be carbon neutral. And so we're definitely on our way to reaching that goal. We've talked a lot about zero energy, which is the site energy, how much the building uses. The other part of that equation, though, that we need to start looking at is the amount of energy it takes to make the products and get them to the site that build the building. And so that's just part of the whole strategy in the carbon neutrality challenge. We want to talk now about what all this means to combine the 21st century education strategies and the energy that we've been talking about.
So obviously safety is something that has to be at the forefront of every decision that we make as design professionals. We understand that really safety begins beyond the front door, really as anyone enters the site even. But for the building, we want to be sure that we're introducing a secure area, one primary entrance for all visitors to enter at the front area of the building. This becomes the first layer of defense. And obviously we're seeing access controls continue to evolve, and the technology continue to change here. But the safety and secure aspect of the front vestibule here, and also the welcoming environment becomes paramount in every school that we do. Kenny also mentioned that students learn in different ways. So we want to look for every opportunity to support students in their education. So things such as learning streets on the left-hand side, where even spaces that would have typically been only a corridor, a means to get students from one part of the school to another, become an opportunity for small group learning or for students to sit and study. So we really have taken a look to capitalize on these non-traditional learning areas and spaces. We also like to be creative in how we are able to utilize different spaces. On the right-hand side, we talked before about Warren County's historic model of trying to utilize the cafeteria space as a multi-purpose space, typically seen as a multi-purpose gymnasium type space. Well, this is actually the latest at Jennings Creek. They have actually utilized that space not only as a cafeteria, but to double as a small auditorium on that campus. So again, look for ways to maximize the flexibility of spaces so that we can, again, address how students learn differently. We also want to look at things such as vertical circulation in the building. Is there a way that we can actually incorporate a social stair so that it becomes a space not only for students to congregate on and to be able to socialize, but really even be able to plug in their small devices and laptops and that type of thing and be able to study and learn anywhere in the building. We also think it's very important to be community connected. We realize in every community that we work in, they're all different and they all have something that they're proud of, and rightfully so. So we always look for opportunities to, again, kind of bring the community into the school because we know that each one of these facilities and each really in any school in any community becomes a community center. So we really want to reinforce that idea. We talked about the use of insulated concrete forms and the idea of really being cost efficient, not only to build, but again, to operate and to maintain. So we want to look at things like life cycle cost analyses to make sure that we're making the right decisions, not just for first costs, and to make sure that we're making a decision that meets the budget, the short-term budget for construction, but long-term, we're making the right decisions for each client so that they don't inherit something that's going to really take a lot of resources to try and maintain over the life of the building. Something that has become more important and kind of as a something that we've been able to take advantage of with the insulated concrete forms is we have just recently adopted the requirements for storm shelters for all new education buildings throughout the state of Kentucky. This has been a process to try and understand what needs to change, but it's been a process that's been much easier because we had already been utilizing insulated concrete forms and the monolithic concrete walls throughout many of these buildings. So we have actually been looking at primarily the gymnasium, or roughly the space equivalent in size to the gymnasium for these tornado shelters. And again, looking at the walls as being insulated concrete forms, and then reinforcing the roof system, and then providing the necessary ventilation, power, the plumbing and water requirements to supplement that space and turn it into the storm shelter that's now required by the Kentucky Building Code. Energy efficiency is something that's just become ingrained in all of our projects and really changed the way that we see and view school design. We really want to look at not only, are there opportunities for PV or, reducing or offsetting the the building energy consumption, but really thinking and taking that comprehensive approach to design so that it's not just an engineering problem. It's a comprehensive approach to energy efficient design that involves the architect from the start. And it's not just something like you're trying to put a Corvette. We've often used the analogy of trying to put a Corvette engine into a Chevy Cobalt or another type of Chevrolet car. You can do that, but it certainly won't perform as well as a Corvette would.
So I want to take just a few minutes and tell you a little bit more in detail about our latest 21E school, which is also Kentucky's second zero energy school, and that's Jennings Creek Elementary. And here is the main entrance on the bus drive side of the building. I'm just going to show you a couple of images about this school. This is one of the this media hub in the building, which is really a 21st century space. It has a area for maker spaces. You're looking at the presentation area for the students here. And then this is what we consider the grand staircase. And there's even some areas built in here for presentation opportunities. As you can see the students there. And as Justin mentioned earlier, the polished concrete floors throughout the building that really did help with the the energy performance of the building because of the lower maintenance that's required. This is the Great Hall. Again, a lot of clear story lighting, overlook space in the balcony. You can see the grand stair at the end. And even though I know people will ask, you've got a lot of high volume spaces in your buildings, and that's true because that's the way we get natural light in. They're just nicer spaces, and building a pancake is not the way to design an efficient building. As long as these spaces that have high volumes don't increase your exterior contact, then you can maintain that building envelope and have these really nice spaces that enhance the educational quality, and not add cost to the building or add energy consumption as well. This is that same cafetorium, which is, if you think about it, the cafeteria is one of the most inefficient spaces in a school because it's only used a couple hours out of the day, and then it sits empty for the rest of the time. So as we look at not only zero energy strategies, but 21st century education, those flexible spaces become so important to just increasing the educational value of every single space in the building. This is the plan of Jennings Creek. And again, it's not the box that Richardsville was, but it is still a very efficient compact envelope. We used to design buildings with metal bar joists with concrete deck on poured concrete on top of that. We've switched to hollow core planks. So now instead of having 24 to 28 inches of space between floors, we've reduced that to 8 inches. And so we can reduce the volume of the building. And again, that helps, if you think about it, not only in energy savings, but if the wall is 28 feet tall instead of 30 feet tall, well, that saves the amount of material it takes around the entire perimeter of the building, and it reduces the first cost. And we were able to get this building in at $204 per square foot. And to give you some idea of comparison, at the time, our Department of Education said a school should cost $221 per square foot. So not only were we at a significantly lower cost for the building, we were also a net zero building as well. So we simply asked the question, given the choice, which option would you choose? Traditional design and construction, not necessarily sustainable, or have high performance features, and no energy reduction beyond the building code. With our 21E design and construction, it's the most sustainable building that you can possibly design and build. It's certainly high performance, and with the 75% energy reduction, capable of achieving net zero if you just add the solar array to it. But here's the thing that is most important to us is the money that we're saving the school district in these energy savings. That money can be applied directly to the classroom and benefit the students' education. And I'm sure in your all's part of the country, there simply isn't any free pots of money going around to school districts. So we found one that we can greatly impact. And so we just feel that this is the right way to design buildings. And I'm going to show you just how Jennings Creek shook out. On the left there is the typical school. And again, I mentioned that in the state of Kentucky at the time, $221 is what you should expect to spend. Without the solar, we came in at $201 on Jennings Creek. And what we did is we just projected those savings, and then we added the solar array. And one thing I can tell you about solar is over the last decade, the cost has come down so dramatically that now, if you look at the Jennings Creek column, the second down, you can see $392,000. That's the solar array. Those kind of decisions we make every day. That's the cost. That's less than the cost of terrazzo floors or a metal roof for the building. So now the solar array has just become a decision that's much easier to make. But when we apply the savings, we can pay back that entire solar energy investment in 7.5 years. And here's what's really, really important is we finance our schools in Kentucky over a 20-year bond. Just think of it as the mortgage for the school is last 20 years. Well, by zeroing out the energy costs and then adding the solar array, we've got a cumulative savings of $3.6 million over the mortgage of that building. And that's the money I'm talking about that can go directly back into education, because the same pot of money in Kentucky that pays teachers' salaries is the same pot of money that pays the energy bills. And I just wanted to end here on our latest school. This is Bardstown Independent Elementary, and it's now under construction. Very similar to the other ones, except now we have a building under construction that has the storm shelter that Justin mentioned. And those, we were expecting that to add a lot of cost. And actually, architects in Kentucky are projecting up to $1 million added to the cost of the building. But because of the way we were designing with the ICFs, we were able to almost eliminate that cost, because as Justin said, the walls, the ICF walls, we already meet the criteria to withstand a direct tornado strike. So all we had to do was fortify the roof and then add the items for the temporary ventilation that has to occur. And we were able to successfully do that without negatively impacting the budget. And this is the plan of Bardstown. And again, you can see it's still very compact in nature. And now we've moved the gymnasium to the end of the building. You can see it at the bottom of the page. And we did that so it was easier to isolate the storm shelter, which is also going to be open to the community. So it is an important feature in Bardstown, which is a city school district. A lot of kids, they don't travel a lot, so it's very easy to get to the school. In the event of an emergency, families from around the school would also be able to utilize the storm shelter. And because of these efficiencies and more, we're now projecting it to be as equal to Jennings Creek at 15.5 EUI. These are just a couple shots inside Bardstown, the renderings. Again, the 21st century impact of non-traditional media centers are no longer just book depositories. So there's a lot of different types of learning opportunities there. Here's another social stair opportunity, and then some small group study areas within the cafeteria. So again, that space is not just used a couple hours out of the day and then set aside. It's used all the way through the school day. And with that, we'd like to conclude, and we'll allow for questions. We'll be happy to talk about those. But again, we just appreciate the opportunity to be able to share with you all what we've been doing in Kentucky for the last decade. So thank you very much.